Good morning to everyone. I'm Dr. Sumi MS. The topic of my today's presentation is General Definition and Size Effects from Unit 1 Introduction in Nanotechnology. On completion, the students will be able to understand the background and properties of nanotechnology and explain the types of nanomaterials and list down the applications of nanotechnology. What is nanotechnology? Nanotechnology is defined as the science, engineering, and application of materials and devices with structures at the nanometer scale. Nanometer scale is ranging between 1 to 100 nanometer. 1 nanometer is equal to 10 to the power minus 9 meters. At nanoscale, the materials can exhibit unique physical, chemical, as well as biological properties that differ from their bulk counterpart material. Historical background. Feynman's vision. Richard Feynman, 1959 lecture, There's Plenty of Room at the Bottom, introduced the idea of manipulating individual atoms and molecules. The term nanotechnology was popularized by Erich Drexler in the 1980s. Unique properties at the nanoscale. Quantum effects. These result in altered electrical, optical, as well as magnetic behaviors at the nanoscale range of materials. High surface area to volume ratio. With high surface area to volume ratio, better increased reactivity can be obtained in the materials. Mechanical strength. Nanomaterials like carbon nanotubes are extremely strong and also lightweight. Optical properties. Nanoparticles can change color based on size. That is, they are able to emit different colors with respect to the variation in their size. Nanoparticles types based on the dimensions. So they are categorized as 0 dimension, 1 dimension, 2 dimension, as well as 3 dimension nanoparticles. 0 dimension nanostructures are generally called as nanoparticles. Example, gold and silver nanoparticles. All their dimensions, all the 3 dimensions will be lesser than 100 nanometer. Whereas in the case of 1 dimensional structures, example nanotubes, they have a tubular structure. Example, carbon nanotubes, and here one of the 3 dimension will not be in a nanoscale range. And another example is nanowires. Example, silicon nanowires. They have better conductive properties. Then 2-dimensional nanomaterials include nano coatings. Example, anti-reflective coatings. They form a thin film structure, and here 2 out of the 3 dimensions will not be in the nanoscale range. And the 3-dimensional nanomaterials are the bulk nanomaterials. Example, nanostructured ceramics, in which all the 3 dimensions will not be in the nanoscale range. Synthesis methods. Nanomaterials can be synthesized by following either a top-down approach or a bottom-up approach. Under top-down approach, we have breaking down bulk materials, and the techniques followed are lithography, milling, and advantages include compatibility with microfabrication. In bottom-up approach, which includes building up from atoms or molecules, and the techniques followed are self-assembly, chemical vapor deposition, and advantages are better atomic precision. Characterization techniques. These are scanning electron microscopy, transmission electron microscopy, atomic force microscopy, X-ray diffraction, dynamic light scattering. These are some of the characterization techniques followed in nanomaterial synthesis. Applications of nanotechnology. Under electronics, we get faster transistors as well as nanochips, medicine, drug delivery, cancer treatment, in energy, solar cells, hydrogen storage, as well as fuel cells can be obtained in using nano methods. in environment, better water purification methods and pollution control sensors are available. Textiles, strain resistant fabrics and ultraviolet ray protection. Future trends. Nanorobots are employed in medicine, in molecular manufacturing, quantum computing, and green nanotechnology for sustainable applications. Size effects. Size effects in nanotechnology. When the size of a material or a system gets shrunk to a nanoscale range, size dependent effects become dominant. These effects are responsible for the unique and enhanced properties observed in nanomaterials. Quantum size effects. At the nanoscale range, the energy levels of the electrons become discrete, affecting the electronic and optical behavior. This is important in quantum dots, where the color of the emitted light vary based on the size of the nanomaterial. Surface area to volume ratio. Smaller particles have a much higher surface area relative to their volume. This increases its reactivity, catalytic activity, as well as interaction with biological systems. Surface energy effects. At nanoscale, a larger fraction of atoms are on the surface when compared to that in the bulk materials, which would create changes in the melting point. That is, gold nanoparticles have get melted at much lower temperatures than their bulk gold materials. Then mechanical strength is higher and also surface energy and better addition properties. Mechanical properties. Nanomaterials can be stronger or more elastic. For example, carbon nanotubes have very high tensile strength and stiffness. Optical properties. Nanoscale materials can scatter or absorb light differently. Example, gold nanoparticles appear red or purple rather than being yellow. Magnetic properties. Nanomaterials may become super paramagnetic rather than being ferromagnetic. That is, they show magnetic behavior only in the presence of an external magnetic field. This is important in data storage as well as MRI contrast agents. Quiz questions on general definition and size effects. Write down the properties of nanotechnology. Explain the types of nanomaterials. List the applications of nanotechnology. Explain the size effects in nanotechnology. Thank you.